Dear student, today we shall discuss another topic of the chapter Chemical Thermodynamics, which is thermodynamic processes. Now, what are thermodynamic processes? These are the path or operation through which system changes its state. Now, what are the different processes? Number one, isothermal process. Number two, adiabatic process. Number three, isobaric process. Number four, isochoric process. Number five, cyclic process. Number six, reversible process. Number seven, irreversible process. So we shall understand one by one. So first is our isothermal process. Isothermal process. Iso means same. Thermal means temperature. That is, system changes its state from 1 to 2. System changes from state 1 to 2, but temperature of the system remain constant. That is, temperature of the system does not changes. For example, now dear student, at this moment your body temperature will be normal body temperature. There is, we can say, 37 degrees centigrade. When you will reach at home, what will be your body temperature? It will be also 37 degree centigrade. But you have changed your state, but your temperature is remains same. Your temperature does not change. That is the process in which the process in which temperature of the system remains constant. Temperature of system does not change is called a isothermal process. So in isothermal process, temperature, say T is equal to constant, temperature is constant, therefore change of temperature say change of temperature is denoted as dt. Is there any change of temperature? No, there is no change of temperature. That is, change dt equal to 0. Now let us consider a system. This is a system. Suppose here some exothermic reaction going on. If exothermic reaction going on here, so necessarily heat will evolve. The temperature of the system should rise, but in order to maintain the constant temperature, the heat energy must go out from the system to the surrounding. I repeat, in case of exothermic reaction, heat is evolved. To maintain the temperature constant, heat must go out from the system to the surrounding. Similarly, if endothermic reaction is going on, then temperature of the system will fall. So in order to maintain the constant temperature, heat energy must enter into the system from the surrounding. So in case of isothermal process, it can enter, it can go out from the system or to the surrounding. So graphically, let us see graphically how can represent. See, this is the temperature constant. So temperature constant means this type of process follow Boyle's law. So if we draw a pressure and volume diagram, so what will be the nature of the curve? So when pressure decreases, volume increases in this pattern. So pressure decreases, volume will increases. So this is the nature of the curve in isothermal processes. So we have we have understood the isothermal process. Second, next is adiabatic process. Adiabatic process means heat energy cannot enter into the system or heat energy cannot go out from the system. As a result, what will happen? Temperature of the system may fall, may rise. For example, again let us draw the same system. So this wall is a such type of wall. Say cannot heat energy cannot enter into the system, or heat energy cannot go out from the system. So that is called Q is constant, that is heat Q is constant, or we can say change of heat, that is dq equal to no change of heat, that is 0. So similarly, if some exothermic reaction is going on, so temperature will rise in the system because heat energy cannot go out from the system. Again, if some endothermic reaction is going on, temperature of the system will fall because heat cannot enter into the system. But in isothermal, what will happen? Heat energy can enter, heat energy can go out. As a result, temperature remains constant. So this is the basic differences. Now, what will be the nature of the car? P and V. It is almost same as that of isothermal process, but the car much steeper than that of the isothermal one. So what is adiabatic process? Heat is remain constant. That means it cannot enter into the system, or it cannot go out from the system. Number third is isobaric process. Same, iso means same. Bar, this bar is the unit of pressure. Pressure constant. That is, system changes its state, but its pressure remains constant. So, pressure, that is P equal to constant. Therefore, change of pressure that is dp equal to, is there any change of pressure? No, dp equal to 0. There is no change of temperature. Now let us take a system. So in thermodynamics, ideal system is, it consists of a cylinder. It consists of a cylinder fitted with a frictionless, weightless piston. So this is a piston. So this is our system. This piston can move up, can move down. Now see, suppose in this system, this type of chemical reaction is going on. Say number 1, H2 plus I2 equal to twice HI. So initially 1 mole, 1 mole, 2 mole. Here also final also 2 mole. That is initial volume 2 mole, final volume also 2 mole. That is, suppose here reaction taking first H2 plus I2, and finally what will give? Twice HI. In that case volume is same. After reaction volume does not change. In that case, this piston will not move up or move down. Volume seems constant, so pressure also constant here. Second example, let us take dissociation of PCl5. So PCl5, it gives PCl3 and Cl2 gases. See here, 1 mole, it gives 1 and 1, 2 mole. 1 mole, it is total is 1 plus 1 plus 1, 2 mole. In that case, volume of the system, see the volume of the system increases. So piston will move up here to maintain the pressure constant. Number third, say formation of ammonia, N2 plus, say N2 gas, of course, N2 gas plus thrice H2 gas giving twice NH3 gas. So in the reactant size, how many moles? 4 mole. And the product side, it is 2 mole. That is, volume decreases. In that case, piston will move here and the pressure maintains constant. So if the volume remains same, piston will not move. If the volume increases, pressure will move up. If the volume decreases, pressure decreases. The pressure piston down to maintain the pressure constant. Now graphically, what should be the nature of the curve? So here pressure remains constant but volume changes. Pressure constant, so volume, so pressure, just see here the pressure constant, pressure volume changes. Pressure constant, volume changes. So this is the nature of the curve. I think we have understood the isobaric process. So our next topic is isobaric process. Number 4, isobaric process. So here iso means same. Here volume, that is V, is constant. That is, system changes its state but its volume does not changes. For example, a solids, any solid, say is the remote. is a solid one. If the temperature increases, volume does not change. Volume also remains same. If changes minor, we cannot observe. This is called constant volume. Any solid, any solid things, volume changes does not changes if the temperature changes. So volume is equal to constant. Change of volume, change of volume, that is dV equal to, is there any change of volume? No, that is 0. Now what will be the nature of the curve? So this is the pressure and this is the volume. What volume remain constant, that is volume does not change. This is the nature of the curve. I think the what is isobaric process? The process in which volume of the system remains constant during its change of state. I repeat, volume of the system remains constant during its change of state. Number 5, cyclic process. Cyclic process means system return back to its initial state. Suppose system start from here, it is the initial position. After series of changes, it returned to the initial state. If the system follows this path, that is called a cyclic process. Dear student, you also always follow cyclic process. If you do not follow cyclic process, then see what will happen to you. So in cyclic process, so since the system returns back to the initial state, initial and final state same, that is change of volume, dB, dV. Is there any change of volume? No, because initial volume, final volume same, because system returned to the same initial state. Change of temperature. Is there any change of temperature? No, because initial same state will reach. Change of internal energy. That is del U equal to also 0. That is we shall discuss later the internal energy. Number 4, change of enthalpy, that is denoted by del H, also 0. So in case of cyclic process, there is no change because system returns back to its initial state. Next is number 6, reversible process. And number 7, irreversible process. These two we shall understand together. The process in which the direction of the say reaction or system can be reversed, but here in this process direction cannot be reversed. So in reversible process, a system can move forward as well as backward, but in irreversible process system can move only in one direction. That is, it cannot retrace back. But in case of reversible process, system can move forward as well as backward. Another important distinction is that reversible process, reversible process occur very slowly, irreversible process occurs rapidly. So one of the example of irreversible process, say burning of a piece of paper. So after burning piece of a paper, the ash come from the ash, paper cannot retrace back. We cannot prepare paper from ash. So it is totally irreversible one. Falling of water from the top of the hill is an irreversible process. It it cannot go back to the top of the hill until and unless some external agency is there. So irreversible process generally it occurs by itself on natural process. Generally all the natural processes are irreversible processes. Reversible process which occurs in both directions. So let us conclude main points. Reversible process which can proceed forward as well as backward. Number one, which can proceed forward as well as backward. Again, all the steps involved in the forward journey exactly repeated in the backward journey. Those steps involved in the forward journey exactly repeated in the backward journey. Number third, reversible processes are extremely slow process. Number four, work involved. Work is maximum. In case of reversible process, work is maximum. So these are 4 points. Reversible process which can proceed forward as well as backward, and all the steps involved in the forward journey also repeated in the backward journey. This process occurs very slowly, and work involved or work produced in this process is maximum. Number two, no, sorry. In case of irreversible process, this process occurs rapidly, very fast. Number two, its direction cannot be reversed. This one direction. Number third, work is minimum. So these are the our some concepts of thermodynamic processes. Dear student, I think you have understood the different thermodynamic processes. The notes of this process, different processes, you will get in the description. So subscribe the channel and hit the like button so that I can prepare more videos and upload notes for you. Thank you for watching this video.